Alright, what's up, everybody? Alright, check this out. Okay. It's raining today, hence the windshield wipers. And it is super foggy. We've got super fog. Let me roll down my window here and see if I can get a clearer shot. There we go. Now it'll focus. Alright, so that's what we got today. And it is raining. It just started raining a little bit ago. And there's literally no sun. There's just white. It's just solid white. Okay? So check this out. And that's everywhere, you know. Everywhere. Okay. I'm kind of up on a mountain. Alright, this is the highest point I can usually see for miles. Anyways, let me get out of here. Let me just show you what's going on the radar. This is a superstorm. This is what I call a superstorm, and it's giving us super fog and super haze and now super rain. And the reason I'm calling it super rain is because A, it's connected to a superstorm. So that little blue dot there, let's just turn the wind off. Let's go to my layers. I'm going to turn that wind and temperatures off because we know that it's around 36 degrees. And let's go back. Alright. First of all, notice that the rain is traveling against the wind. And if you notice in the middle of the screen, you look at that white stuff appearing. That wasn't there 20 minutes ago when I checked. And it is highly indicative, of materials in the atmosphere. Materials that, like metals, heavy metals, and they're getting hit with a frequency, and you can see that frequency. You can see those lines. See the lines in the clouds? On the center of the screen, you can see the frequency as it's reacting. You can even see like a horizontal line being shot across the screen. If you look here, let's move this over. You see all those random light gray dots just appearing and disappearing to the left of the white frequency cloud that I just showed. That's all like nanoparticulates is what that is, of aluminum, barium, strontium, smart dust, nanotags, sulfur dioxide, amongst a bunch of stuff. And so look at how big this superstorm is. Zoom out just a little bit. A little bit more. A little bit more. Let's go a little bit more. Yeah, it stretches all the way to the East Coast to North Carolina. Let's just move it over a little bit. All the way out into the ocean. You know, that's ridiculous. Myrtle Beach. It's just passing north of Myrtle Beach. I just moved from there. Look at this. It's going all the way. It's coming up from the Gulf. And there's a big rotation right here in the Gulf. Look. Check this out. Boom. There's your low pressure system or high pressure system, one of the two. And check this out. There's a massive, that's your high pressure rotation. Now your low pressure up here, this is your low. This is what they're manipulating right here to make it extremely cold up there. All right, that's why we've been experiencing record colds up there in the north, in those areas right there, because that massive low is keeping the cold there, and they're creating this massive high down here to keep it there. So, and what they're doing is they're using these frequencies to drive this rain north. Look at this. Let's turn that wind off. Boom. Look at this. The cloud has developed a little bit more. So a little bit of time has passed. This gives pretty good updates. Now you notice the moving clouds, because I've got the clouds set to on. So notice there's moving clouds generating. That's the white and the gray. Well, they're also indicating the stationary fog, the haze. If you look, there's a light gray everywhere. Why is this huge patch just stationary, not changing ever? And why does this huge patch persist across the entire country? And if you notice, it's coming from the south. It almost looks like it's coming from, Torreon. Even further south than that, down into Durango and Sombrerte or whatever that is. So, and it just comes all the way up the United States, cuts across Texas, and fills. It's going right along the path of the storm, preceding it, and it's going all the way up into Canada. Goes all the way to West Virginia, the thickest part, but there's a haze everywhere, and they're showing it in cloud formation, but it's stationary. It doesn't move. It should move. This other stuff is moving real fast. Why isn't this stuff moving? Why isn't this stuff moving when everything else is moving so rapidly? And it's real pixelated. It's like it was painted in or something. I don't know what's going on there. But anyways, look at that stream. Look at that stream go across San Angelo. That bright green stream. That's crazy that it's moving like that. That's fast. It's only over a hour time period. 1 hour time period. It goes from 9:30 to 10:30. Yep. 9:30 to 10:30-ish. It's crazy stuff. So I just wanted to document that and tell you my opinion. That's what I think's going on, because I know they're using the Doppler frequencies the microwave frequencies to manipulate the nanoparticles in the air to create these high and low pressure systems. And I know that by looking at the radar, it's going to pick that stuff up. It's going to pick up that activity, and they can't hide it completely, you know. So that's my take on it. Peace.